My 4-9 videos are brought to you by the Lego Dot because I'm at my office and I don't have access to my Legos, and this is all I had in my bag. This last section is kind of a hodgepodge of topics, and basically we're looking at how do people try to convince you of things using numbers. And the whole goal of this class was to learn how to think critically using numeracy, using quantitative information. So we're looking at things of how we can misuse sampling to try to make an inference about a population that's incorrect. Some common misuses of statistics, and then we already talked about this in 1.3. We'll look again one more time at a graph that could be manipulated or just kind of poorly put together where the visuals don't match the quantitative data. So our first deal is you should be very mindful anytime someone is sharing with you information about a study, particularly a statistical study, of the sample. There needs to be a description of the sample. And as we talked about in 4.4, the key component of any representative sample is an inclusion of randomness. Random selection. We talked about the 4 types of processes that we selected. So we have the population, and we let each individual in the population have equal chance of being selected, and then we randomly select in amount of items or individuals for our sample, or we systematically select them, or we do a cluster sample stratified, those types of things. That needs to be employed to make a selection. Unfortunately, there's often things, study reports, advertisements is a big one, where the size of the sample is not reported and how the sample is collected is not reported. So our author looks at the first one of just, hey, if we don't tell you how many people were talked to in a sample, that's a problem. Here's an example. 4 out of 5 dentist surveys recommend this particular chewing gum, so you should now buy it because it's so highly recommended. Well, if we look at just the claim here, 4 out of 5, 4/5 is 80%. Well, that's 0.8 or 80%. So the claim here is 80% of blank dentists. Now, it's said surveyed, but we don't know how many. If it was 5 dentists surveyed, then who cares? I looked up how many dentists there were, and there's like roughly, we'll say approximately 250,000 dentists in the US. And these are general practice and orthopedic practice, orthodontics, all the rest. So if we wanted to survey all of these, that would be the population, and make an inference on this, we're looking at what is 80% of 250,000, approximately. I'm getting 200,000. But there is no way this chewing gum brand talked to 250,000 people. In fact, we have no clue of how many people they talked to. How many people did they actually survey? So how many do we think they would need to survey to make this meaningful? There's actually some theory on this. If you take our stats class here at Jackson College, you'll learn that we need an n times the proportion, so that's that p times 1 minus this p. This product needs to be greater than or equal to the number 10. So we can calculate precisely how many. I'm not going to go into why this number matters, but there is an amount in order for us to make inferences. But if we fail to do this randomly, it doesn't matter the amount of people we talk to. It's a garbage inference. So, bottom line here, as our author's pointing out, they didn't give us information on how many dentists they surveyed. They also don't give us information on how they surveyed them. Now, to be fair, that would make a pretty boring advertisement. We're trying to convince someone to buy gum, and if we're going through the process of how we got to this 80%, people would tune out pretty quickly. So while they may actually be reporting a factual thing about their survey, the fact that we don't know the sample size, we don't know how many they talk to, could make this a completely meaningless statement. And even worse, it could be a false statement about the actual population. A second option, or a second problem with samples, is when we rely on volunteer participation. And again, note, if we're asking people to volunteer to participate, this lacks a random selection process. So that's the problem, and of course that means there is bias. In this case, anytime someone is volunteering to participate, they have skin in the game. They're interested in it, so they have a strong opinion, and that is only going to represent people with strong opinions. Remember, the goal of any type of sampling is to reflect the population. So here we got a national poll. We're conducted by telephone to gauge the favorability rating for a particular candidate for the presidency. What types of people might not be represented in this survey? Well, it depends on, like, if we're talking about a telephone, people with cell phones. Now, maybe our author is referring to telephones as cell phones. And then people without phones also might not be in there. And then if we're ignoring those issues, and then it's people who don't answer calls from unknown numbers. People who don't and I'm sure many of us fall into this category. There are other types of studies that have, as our author puts in, built-in bias because volunteers generally don't represent the population at large. There are studies where we need people to participate for longer periods of time. So some medical studies, you need to check in and take a pill and be observed. And in those cases, we're looking at unemployed people could volunteer for those research studies because they could get paid. Also, they have the free time. More college students might be available, or high school students because they have the free time. Non-working, non-full-time working people, people without children, or people without those who depend on them for care. So it's just a big problem with representing an entire population. Another issue is prior times, in olden days, typically men were the primary participants in the studies, and then we tried to generalize these results to both men and women. There's some obvious differences between men and women, just physiologically, but there are other things that are different between those two types of populations. And so making an inference that has only included men or overly represented men is not going to be a good inference onto women. A third type of issue with samples is when we rely on convenience. Again, as I've stated before, this is another type of non-randomness. So lacks random selection. Here our author talks about someone's trying to do a study on Midwest sports, and they go to a sports bar because they want to get a drink and eat some good food, and they talk to 300 people in the general vicinity. That's not random. They're at a sports bar, so they're going to get the opinions of people who are already into sports. It's just, there is no inference upon an entire population. So convenient samples are garbage garbage samples for inference. They're fine to talk about the group of people you talk to, right? You can say, these 300 people, this is what they think about. This is how they think about things. But beyond that, they're no good. In this example, we got an educational researcher wants some data on the number of hours per week that average college students study outside of class. And they send an email and they only get high-level chemistry courses. Well, chemistry courses tend to have, and physics courses that respond. These tend to require more study, and so you're going to get a higher amount of time spent studying because those students need to spend more time because the material is complex. It's like math and English mixed together, right? It's kind of like this course, only, in my opinion, worse, more challenging. Okay, so as I said, I'm kind of skipping around this hodgepodge stuff. The key here is unknown samples, volunteer samples, convenient samples. These all are problematic for making inferences onto a population. When you're reading studies, when you're looking at advertisements making claims about what a product can do, when you're hearing news reports about beliefs that people have about politicians or the economy or anything, you need to know how was the sample collected, how large was it, what kind of random process was it, who's in the sample, in order to know if those inferences can be made onto a general population. Could they be good? So another place where things can get misleading is ambiguous averages. So what we mean here is this word average, as we've learned in, I think, 4 or 5, could be measured as a mean, a median. Those are the two main ones we talk about. And then there's mode and mid-range. And recall that the mean was reported if there's no outliers. And we also said it's the best measure of average if it's a normal distribution. And the median is best or most accurate if we're talking about a data set that has outliers. And we would get more into this in our stats class if you want to get further, a better understanding. So here we got a nice little example of, we got 4 salespeople employed at a store, and it's the length of employment, and we want to talk about, hey, people stay at this store for a long time. We hire salesmen here or salespeople, and they love working here, as you can see by the number of years they stay employed. So let's calculate the mean. We're going to call this a sample mean, and I'll just kind of do this by hand. So we got one employee that's been there for 22 years and then 10 years and 2 and 2. So we add up those numbers and divide by how many employees. There's 4. So I'm looking at 32, 34, 36 divided by 4. So we're looking at an average of 9 years of service, or a mean of 9 years of service. But then if we look at the median, now I've listed them from highest to lowest. Choop choop, we get this middle 2. So we take the mean of those 2. I get 12 over 2. Oh, that gives us 6 years of service, which is a little bit less, not crazy less, but still this is a little bit more accurate, because I would say that 22 looks like an outlier. Well, then we skip over here. What's the mode? That's a 2. What's the mid-range? Recall that mid-range is the maximum plus the minimum divided by 2. That's 24 divided by 2, so that's 12 years of service. If the employee, I got that not in view. So we had the mode was 2, the most repeated, the mid-range maximum plus the minimum divided by 2. We got 12 years of service. If we wanted to try to mislead someone, we could say, oh, the average years of service is 12 years, as calculated by the mid-range, because it makes it look like that employees stay there a really long time, on average 12 years long. But this is misleading, because really the 6 years is more accurate due to that that 22-year length. So always be mindful when someone talks about the average, which average are they talking about? Like, how do they calculate that average? And are there really large or really small data values in the data set that could make one of those measures of average a little more inaccurate? For example, anytime we talk about income, the mean is the wrong measurement of average, because as soon as you put someone in there that earns lots of money, as we looked at in 4 or 5, that makes the average look much larger than it actually is. The next section is, okay, now we're going to send out a survey to get answers from people, and the responses we get aren't good because we had bad survey questions. And these fall into several different categories. One set is when we ask too many things in a single question. And so when a person responds, we don't quite know what we're getting. For example, do you favor a waiting period for guns sold? This is an excellent question and a survey question, because we're going to get people's opinions about whether or not there should be a waiting period before we sell a gun. The second question is not a good question because it asks two things. Number one, should there be a national gun registration program? Okay, yes or no? And then number two, how should we fund that? And really, we're saying, should crime control dollars be spent on a registration program, or should they not? And so when we get responses to number two, we might be getting people saying no to the spending, or we might be getting people saying no to national gun registration. We don't know which. So if you're, say, someone who's against national gun registration, and you think the population as a general is going to be against this thing, would be against spending for this program, but outside of crime control, you would put this in here to try to make it look like, hey, the population is not in favor of a national gun registration program. Where really maybe the population is in favor of it, just don't take our dollars already allocated to crime control away from it. So we would need to parse these into two separate questions to see, what does the general population really believe in this area? Other questions, maybe we ask a biased question from the get-go. So how we ask the question is important. That was an example that we just looked at as a double-barreled question where there's multiple ideas. Using double negatives can be confusing. And then just using confusing word choice. So when you give a survey, it should be clear and simple language, because you want to know that the person understands the question that's being asked. So you want to avoid the highly technical language. And if your goal is to understand what people think, you want to make it easy for them to give their opinion. If your goal is to mislead people, then maybe you would do some of these things so that your survey results match your goal. Here's a couple examples. Are you going to vote for candidate Jones? We should stop there, right? If we want to know if a person's going to vote for him, ask them that question. Here we've added a bit of biased information, even though the latest survey shows he will lose the election. Right? So we're essentially saying, are you going to vote for candidate Jones even though your vote's not going to count, basically? So that might sway someone to say, no, I'm not going to vote for them. I'll put my vote somewhere else. Next one, do you think people will live longer if they were on a diet? This is vague. What kind of diet? Everyone has a diet, right? What you eat is your diet. Is it a vegan diet? Is it a meat diet? Is it a vegetarian diet? Is it a Whole Foods vegan diet, like no cook? What's that thing where you only eat foods that have never been exposed to a temperature above a certain degree diet? Is it only red meat? Is it only candy, like from Elf? So it needs to be clear what we're asking. Next one, are you in favor of a national health program? We should stop there, right? This is like federal health care. I think national might be a little misleading, And program is misleading too, or unclear. Are we talking about health insurance? Are we talking about a program that encourages people to stop smoking? Like, what is this program? And we've talked about insurance a lot in the public domain, so that might be clear. All right, but we continue on. And do you think it should be subsidized by a special tax? Okay, well, this is a second question. So, should there be a health program? Should it be paid for by a special tax on top of all the other taxes? And then, as opposed to other ways to finance it, such as a national lottery? Well, this has really got three things in it. Like, national lottery. What? How's that go? And then finally, do you feel that it is not appropriate to have areas where people cannot smoke? Okay, double negative, right? That's a little confusing. I think we're talking about banned smoking areas. So should we stop making it like banned smoking areas? Other issues in surveys that can crop up is if people think that their identity might be shared in the responses. So the author is pointing out here, participants will in some cases respond differently to questions based on whether or not their identity is known. I went to a small private Christian college for undergraduate. It was actually in Barron Springs, Michigan, called Andrews University. And in the student handbook, if you drank alcohol on campus, or even off campus, I think, if I'm remembering correctly, you would be expelled from the school. You'd lose all your scholarships, you would lose all your money, you were just gone. And I think it was an English class, or it was one of the classes, they came in and administered a survey, and a bunch of the questions were like, how often do you drink? How often do you take illicit drugs and all these other things? And if a student taking that survey didn't think they were anonymous, the correct answer is, I don't ever drink, regardless of whether or not that was the truth, because you're going to get expelled, right? So same idea is like if a police officer pulls you over and says, do you have anything illegal in the car? You're going to say no, probably, no matter what, because you don't want to get a ticket or you don't want to get in trouble, and they can't search your car unless they have probable cause. So anonymity, being unknown, I guess that's a little different for the police officer. That's changing your response based on the interviewer is a big deal. Okay, the third thing here is using percentages. So we beat this into you all in Unit 1. New minus old was the change between two numbers, or we could also call it the difference, right? The exact amount between two numbers. And then we had the relative difference, or relative change, or percent difference, or percent change, which was new minus old divided by old, which is a way to compare, hey, this new number relative to the old number, how much change is it? How much percent change? And then there was another one that we talked about a little bit, which was like, hey, if we take a part and divide it by a whole, that's the percent this part is of the whole. So how much of the whole is this part? What percentage of it? This can be used all the time in the public domain, particularly in political things when we're talking about spending. So the example here is, say, hey, during my administration, expenditures increased a mere 3%. It's a tiny amount. And then the opponent says the spending increased $6 million. That's a crazy amount. Well, both of these numbers could be 100% accurate relative to the actual budget, and they're vastly different looking, but they're both accurately describing the situation. And calling 3% small is maybe a little bit misleading, but then calling 6 million huge or whopping is also a little bit misleading. We need to have a complete picture. when talking about percents and differences. So let's look at this quick example of it. In North Carolina, there was an individual income tax rate in 2013 was 7.75%. And then in 2015, this rate dropped to 5.75%. Notice this is the old amount because of the 2013. This is the new amount because of the 2015. So what is the actual change or difference in the two tax amounts? We're going to do 5.75% minus 7.75%. That equals negative 2%. In other words, there was a 2%, we should say it this way, when, what, how much. From 2013 to 2015, NC's income taxes decreased by 2%, right? A tiny decrease. Well, what was the relative difference in the two taxes? So that's taking this amount and dividing it by the original amount. In other words, that negative 2 divided by 7.75. So what percent of the original amount is the decrease? That happens to be approximately, now I'll write 4 decimal places here, 2.581. In other words, multiplying that by 100 gets us a 25.81%. And we could write this same sentence from 2013 to 2015. NC's income taxes decreased by 25.81%. Now, what's a little problematic here is that both this percent is the units on this, and this percent is the relative change from the previous year's amount to the new year's amount. So 25% of this 7.75 is this negative 2, or this amount of decrease. So these are different percentages. All right, so if someone earned $40,000 in income, what is the difference this tax cut had in that person's income? We're just saying, hey, they are going to pay this much less, $800 less. We could look at the calculation by doing it this way: 7.0775 times 40,000 times 0.0575, and we could do the same thing and get the how there's 25% decrease. This $800 represents a 25% decrease in the amount of taxes they owe. But maybe that's a little bit of overkill here. So which of these three differences would be used by someone wanting to argue that this tax cut won't hurt the state's budget much? Let's see. Oh, I think the 2%. So we might say the state, North Carolina, will receive 2% less. Now this is, if we're going to be, this would be a little bit misleading. We should really say we'll receive 2% less per taxpayer. If we wanted to say it's going to have a devastating effect, we might say NC's tax revenue will decrease by 25.8% relative to 2013. So they're receiving 25.8% less in 2015 than they did in 2013. And they're all correct mathematically, but each one is looking at a different type of number, a different calculation. Okay, the last little thing to look at is implied connections. This happens in advertisement all the time. There's an implication of a connection without really any sort of evidence, any sort of study, any collection of a sample and an analysis of the results to make the connection. And then to keep from being sued from like false advertising, we throw in words of uncertainty, may and suggest and some. And these connections may not actually exist at all, but the advertising is the advertisers can do this, and it's left up to you to note that there's really nothing of meaning being stated. For example, eating fish may help to reduce your cholesterol. Well, did they take a random sample of people and break them into two groups and give one group a fish diet and the other group a non-fish diet and try to keep everything else the same? Probably not. And there's no evidence, there's no support, there's no explanation of how they came to this suggestion, right? Excuse me. Studies suggest that using your exercise machine will reduce your weight. So this is a pretty concrete statement. This is not. And what studies? Did they actually study this exercise machine? I think it's pretty clear that exercising helps with weight management along with a healthy diet, right? So this is really a completely meaningless statement. There is nothing about this particular machine that would do anything. And I think it's pretty clear that any exercise program is good for anyone's health. And whether you use this machine or any other machine isn't going to make much of a difference. Although if you watch any of those, anyone trying to sell you some sort of exercise program or machine or whatever, they all make the claim our product is better than everyone else's. And then taking calcium will lower blood pressure in some people. Sure, right? They probably were able to show in a sample that some of the people had their blood pressure lowered. But if it wasn't randomly done, if we don't know anything about these people specifically, what was it that helped these people lower their blood pressure? Was it the calcium that they were taking, or was it something else about those people that makes it so that you taking the calcium, it probably will have no effect on you, or it may not. We just have no clue. So the key thing in all of these is these are saying nothing, and yet they're saying something that might make you want to purchase their product or convince you that it's worth your while to get it. So the last bit from this section and from this textbook is our misleading graphs that we already did. And I'm just going to real quick graph our 2013 North Carolina tax rates on these two different scales and remind you of when you don't include zero, the visuals will misrepresent the differences between the two numbers. So remember 2013's income tax rate was 7.75 and 2015's income tax rate for North Carolina was 5.75. Visually speaking, this looks like, let's see, if I count these lines, 1, 2, 3, 4-ish lines. It looks like it's about half the distance between these two. So this makes it look like, visually, taxes are cut in half. Whereas if we graph this thing on with a graph that includes zero, we get a visual representation that is far more accurate to the amount. You can see that there's hardly even a line in between the two. And this is the accurate visual representation that there's only a 2% difference between the two. So watch for those things. Always look at your axes to note, have they excluded something, particularly zero on the y-axis, that will zoom in? Like what's happened is we've zoomed in on this difference right here, to highlight and exaggerate visually how far apart these are. To the mathematician or to the mathematical person, you're like, oh, it's 7.75 and it's 5.75. There's only it's only a 2% difference between these two.